In this lecture, we're going to see how we can declare and use references in our C++ application. Again, a reference is an alias variable that you can use to reference an original variable and use that reference in pretty much the same way you use the original variable. Let's see how that can work in C++. Here is a simple example. We have two variables. One is an integer, we have 45n. The other is a double, we have 33.65n. We want to set up references to this variable, and the syntax is ridiculously easy. For the int value, its reference is going to be something like int ampersand. You put the ampersand symbol, you say the name of the reference, and you initialize this with the value in the variable that you want this to reference. So reference to int value is going to be referencing our integer here, and we can use this name to reference this variable here, and it is going to be like we are using the original variable, which is int value here. You're going to see how this works in a minute. We can do the same using assignment initialization, and down here you see that we have an example for the double value, and we have a reference to it. Once we have these references, we can use them like we use the original variables. For example, if you come here, you see we are printing stuff out. If we print int value, we're going to get the value printed out. If we print double value, we're going to get the value printed out. We can also print through references. You're going to see that they are going to print exactly the same value as we have in the original variables. But the interesting thing is going to be that if you print the addresses through the original values and print the addresses through the references, you're going to get the same addresses printed out, which is really going to say these two variable names are almost exactly the same thing in C++. And this is really cool. You can use the reference as if you are using the original variable name in your C++ code. We're even going to try and go through the sizes and print them out, and you're going to see that they are going to be exactly the same thing. And we are going to see how important this can become in C++ code as we go through this chapter. Okay, now that we have the reference declared, we can go through that and modify the value. And if we do that, the changes are going to be reflected in the original variables. And if we print stuff like this again, we're going to see that the changes are going to be reflected in the original variables. Okay, if you modify the original variable, the changes are also going to be reflected in our references. And this is exactly what we would expect from our references. Okay, so this is really all there is about references. They are aliases to your variables, and you can use them pretty much the same way you use your variables. Let's head over to Visual Studio Code and see some of these things in action. Here we are in our working directory. The chapter is references, and the lecture is declaring and using references. We are going to grab our template files here, and we're going to put them in place, and we are going to open this in Visual Studio Code. We are going to set up an int variable. Let's call this data or int data. This is going to be much more descriptive, and we're going to initialize this with a 33. Why not? And we're going to do a double and say double data, and we're going to put in a 55 in, and we're going to set up references to these variables. And again, a reference is an alias that you can use in pretty much the same way you use the original variable. So we're going to set up a reference to int data. We're going to say int reference, main reference, by putting the ampersand symbol here, and we're going to say ref int data, and you initialize that with the variable name you want this reference to reference. And here we want to reference int data, so we're going to pass in int data, and this is going to be it. Our reference is declared. We can do the same for double data, so let's do that. Double, and we're going to say it's a reference. We're going to say ref double data, and we're going to reference double data here. So let's do that. Okay, let's bring up our terminal and see if we can compile this code here. We're going to compile with GCC like we always do. And let's close this thing on the left because it takes up some of the space here. The build is good, so this syntax is valid C++ syntax. So what we can do is read values from all these things and show you that they really are the same things. So we're going to print stuff out, and I am going to put here some code, and I am going to come back when I have typed this. I don't want you to suffer watching me type these things. Okay, here I have the code typed out, and you see that I am just going to print data through the original variables. I am going to print the actual data and print the address of the variable, and do the same for the double data, which is of type double. How convenient. And we're going to print references. We're going to print the reference and the address of the reference, and we're going to do the same thing for our ref double data here. Let's try and build this with GCC. So we're going to run the task to do that, and we are going to clear. The build is good, and run Rooster. If we run Rooster, you see that, let's put a separating line here so that we see the entire thing. So I really like to see my things easily. So let's do that and build again. Okay, the build is good. We can clear and run Rooster now. And we're going to see the original data. Int data is 33. The address is this guy here. We have double data. The value is 55, and this is the address. If we look at our references, we have exactly the same thing. The addresses are even the same. It really is like we are using the original variable, and this is really cool. It can allow you to pass data around much easily using references, and whatever you are using when you have sent this data, for example, to some other file or some other function, you're going to be affecting the same data. Okay, so you're not going to be making copies, and we're going to see how cool this can be, especially when we get to working with functions. This is going to be super cool. Okay, now we have seen that the references are really referencing the original values. Let's try and modify the data through the original values and see that the references are going to pick up the changes. Let's do that. We're going to take int data and change that to 111, and we're going to take double data and change that to 67.2. Why not? And after we do this, we're going to print data again. So we're going to grab the code here and use that again here, and we should see the same changes applied. So we're going to build with GCC. The build is going to be good, as you see here. And if we clear and run Rooster, we are going to see that the value is 55. Let's put a separation line in here. This is cramped, and it is really hard to see what is happening here. So I am going to put an stdendl in here and build again. So let's do that. And the build is good, so we can clear and run Rooster again. And now we see things separated out, and it is easier on the eye. Here we have int data to be 33 and double data is 55. And we are going to print our references, which are going to pick up the same things, because a reference is really an alias to the original variables. But if you go down, you're going to see that the data has actually changed. Int data has changed to 111. And double data has changed to 67.2. And the interesting thing is that the references have also picked up those changes because they really are referencing the same things in memory. It's like we are using the original variable to read these things like we are doing with references here. And this is really cool. Here we have used the original variables to modify data, but we can also modify the data through references, and the original variables are going to pick up those changes. So let's do that. We're going to say ref int data, and we're going to change this to 12, for example. And let's use 1014 or 12. This is going to do. We're going to do ref double data and put in another large number, let's say 1000.45. Why not? And we're going to print the data again. So we're going to grab this and print stuff out again. So we're going to go down and put in the code to print stuff. And you see it's going to use the original variables and the references. And we should see the changes reflected in our terminal here. So let's do that. And we're going to build with GCC as we always do. The build is going to be cool. We're going to clear and run Rooster. We're going to see that we have 33 and 55. The references are going to pick that up. That's what we have here. We're going to put in 111 and 67 through the original variables, and the references are going to be picking that up. And we're going to use references and modify data. You see that the original variables are also picking that up because we are really modifying data in the same memory location. That's why these changes are being shared between references and the original variables. And this is really all we set out to do in this lecture, to show you how you can set up a reference and prove that the changes we do either through original data or references are reflected between these two guys, meaning references and the original variables. We are going to stop here in this lecture. In the next one, we're going to do a comparison between pointers and references because they seem to be doing quite the same thing. Go ahead and finish up here and meet me there.